Hello everyone. So today we are going to solve a very interesting problem that came in NEET 2025. This was thought to be one of the toughest problem, but we are going to solve this problem with very simple methods using concept of physics, just understanding the curvature of the system. So this problem was based on surface tension. It is from the fluid dynamics. So let's dive into the problem and understand what it wanted to say, and let's solve it. So the problem states that consider a water tank shown in the figure. It has one wall at x is equal to L and can be taken to be very wide in the z direction. Means it has in 3 dimensions, in which we are shown the 2D figure of the surface tension problem. While filled with the liquid of the surface tension S, the density rho, the liquid surface make an angle theta naught, which is very less than 1, means it is a very small angle, and with the x-axis the x equal to L. So if yx is the height of the surface, then the equation yx is, you have given 4 options. You have to take theta as given, and you can solve it with the help of slope equations. So let's start with the problem. If we see this surface is shown as a curvature, and it can be any equation. So we can take that y is equal to fx, right? So primarily we can see that y is equal to fx can be taken as any equation, okay, any surface equation. To find the slope of any curve, we can just differentiate it. If we take this curve and we take 2 points here, let's suppose P1 and P2, we can take any 2 points. We can say that this P1 and P2 has a difference in their height, which we can take that h is equal to y. So we can see that the change in the pressure difference P2 minus P1 can be computed using the surface tension times the change in curvature. So what is surface tension? Surface tension tells the property that how much a thing is curved, how much the system is curved. So it helps to understand the curvature of the system. So suppose this system is curved like this much, this can be curved more like that. So this system is curved this much, and this is curved more, and a spherical system is curved even more. So it is a property by which we understand the curvature of a system. But how do we find the curvature of the system? So we can use y is equal to fx for any equation of the curve. We can find that how much it is curved, that how much this theta angle is curving. We can just differentiate it, and we can find that how much it is curved, right? So this is the slope of the curve. Then we can again differentiate it. This will gives you the exact curvature. So it is the rate of change of slope which defines that it is the curvature of the system. So we can apply this in the equation number 1, as stated that the change in pressure is equal to surface tension times the change in curvature. So while applying it, P2 minus P1, we can just say S times of d square y by dx square. So this is equation 2. Okay. So we have seen that this change in pressure here point results in the change in the height. So we can write it as P2 minus P1 is equal to rho g times h, where h is equal to y, so we can just write it as rho g y. Okay. So then we can just substitute this equation as P2 equal to P1 times plus rho G Y. So this is the change in pressure. So what we have to find? We have to find an equation in terms of d square y by dx square and rho G x times an S. So we can directly substitute this in the equation number 2, and we can just find that change in pressure delta P is equal to P2 minus P1 and equal to rho G Y. Okay. So we know that P2 minus P1 is surface tension times the change in curvature, which is nothing but delta P is equal to S times d square y by dx square. So delta P is nothing but rho G Y divided by S, which is equal to d square y by dx square. So this can be seen in the equation that rho Gy is equal by S is equal to d square y by dx square. So you can directly say that the option number 2 is the correct answer. So this gives us the understanding that how curvature of the system and surface tension is related to the change in pressure, and this question is solved very easily with the understanding of the curvature. There is an alternate way to solve this question also using calculus. We can see that in the next video. So to find the detailed analysis, how much force it is putting on the wall and how the components are dissolved, to analyze it in 3D format, we can use calculus. But for a very simple analysis and during the very just conceptual understanding of the curvature and the pressure difference, we can just solve it using this equation. So thank you and keep learning.